Good morning, ma'am. This is our topic, Lesson 6, the model of database access control. Database access control is the application of policies, procedures, and technology that control who can access data, what actions they can take, and under what condition. It is critical for data security, preventing unwanted access, and adhering to rules. Standard models include discretionary access control, mandatory access control, and role-based access control, which dynamically evaluates attributes such as user roles or environmental conditions. Each variation provides distinct advantages and is suitable for varied organizational objectives and security requirements. Next.
The concept of how they work. Database access control models is regulate and restrict user access to sensitive data within a database management system to preventing unauthorized access, to accidental data loss, and malicious activity. So the first is principal least privilege. Users are granted to minimum level of access necessary to perform their tasks, reducing the risk and misuse or the accidental damage. The principle of least or privilege, this is the principle ensured that users are given only the minimum information required to perform their tasks. For example, a data analysis may only have a read access to specific database rather than write or delete information. This minimizes the potential for accidental malicious data change. And the next is access, access control lists or ACLs. Define the permission for users or group specifying what action or read, write, and execute they can perform on specific resources. So the ACLs control list is define the permission to granted to user or group for specific database resources. Each entry in ACL specific is user group is the user group or the individual or group the rule of apply to. The permission is what the action they can perform, such as read, write, or execute. For example, an ACL might allow the database administrator full access while restricting the regulate user the read-only access. So the next is authentication and authorization. So authentication is verifies the identity of user, like via credentials like password. So the authentication is confirm a user identity usually through credentials like surname and the password, or biometrics or security token. For instead, en- entering a username and password when logging into a database verifies your identity. So, and the next is, and next and last is authorization. Determines whether the authenticate user has affirmation to access a specific resources. So the authorization is determine what the action of authenticated user can perform. It's evaluate the information based on the rule of ACLs. For example, once a user is authenticated or authorization, check whether they can view, edit, or delete specific data. These concepts work together to ensure that only authorized users can access the right data at the right time and to perform the correct action, thereby safeguarding the database.
This is the models of our topic. Discretionary Access Control or DAC. Description. The resource owner decides who can access in and what level. How it works. Permission are assigned based on users defines rules using ACLS. Security decisions are decentralized. Use case. Suitable for system where flexibility is needed but less secure compared to another models. Second, mandatory access control or MAC description. Access is regulated by a central authority based on predefined clearance levels and classification. How it works. Users are granted access based on their security clearance and a classification of the resource, and users cannot modify permission. Use case ideal for high security environments like government or military system. And the third, rule-based access control or RBAC. Description: access is assigned based on organizational rules rather than individual users. How it works. Administrators define rules with specific permission, and users are assigned rules that correspond to their job function. Use case: common in corporate environments due to its simplicity and scalability.
Good morning everyone. Today I'll be discussing the real-world applications. Discretionary Access Control or DAC. In DAC, the data owner or administrator determines who can access data and what actions they can perform. Permissions are assigned based on user identity or group membership. Application used in relational databases like SQL Server, where table owners grant permissions to other users. Common in small organizations where individual administrators manage access right for their teams. Example, a project manager grants team members read or write permissions to specific project files. Next is the Mandatory Access Control or MAC. Access permissions are determined by a central authority based on the predefined rules such as security clearance levels and data classification. Application often used in government or military systems where sensitive data requires high security. Organizations classify data into levels like confidential and secret and assign user clearances accordingly. Example, a defense agency allows only users with top secret clearance to view classified documents.
Role-based access control (RBAC). Permissions are assigned based on roles within an organization rather than individual users. Roles correspond to job functions. Application: widely used in corporate environments for managing access at scale. Simplifies administration by assigning permissions to roles rather than individuals. Examples: a hospital uses RBAC to grant doctors access to patient records while restricting administrative staff to billing information.
Okay, everyone, we already arrived in the summary and conclusion. For our key takeaways, discretionary, mandatory, and role-based access control are access control schemes that address different security concerns. DAC provides flexibility, MAC stresses confidentiality, while RBAC focuses on integrity. Each model is designed to support unique business goals and security requirements. And for best practices, number 1, it has implemented the principles of least privilege across all models. Number 2, regularly audit permissions to ensure compliance with organizational policies. And 3, we have used multi-factor authentication for enhanced security. And number 4, combine models for layered security in complex environments. By understanding these models and tailoring them to organizational needs, business can effectively safeguard sensitive data while enabling efficient operations.